Welcome back to my channel Chemistry Drive with Nadvanisa. Students, don't bother about your term 1 exam. Definitely you will come out with flying colors and you are going to do incredibly well in your term 1 exam. In the previous video, I have discussed you about the chapter Biomolecules, in which we have taken up the topic carbohydrates and we have discussed about its types also. Now we have taken the topic glucose from that chapter, Biomolecules. Now I'll be taking some of its properties and discussing about its structures and the reactions. So let's start with this chapter, and we are taking the topic glucose. Glucose, glucose is present as dextrose in grape sugars, and you can say it is a sweetening agent, and it's present in the corn sugar as well as in the blood sugar. It's also considered as blood sugar. Its formula is C6H12O6. Okay, this is the formula for glucose. If we look at its manufacturing process, glucose can be synthesized from two processes. The one is from the sucrose, that is also known as the cane sugar. So we will take in a cane sugar C12H22O11. It will undergo hydrolysis. On hydrolysis, it will produce one molecule of glucose and another molecule of fructose. So we will only take about glucose. The second process, if you look at it, it can also be manufactured by starch or cellulose. So on undergoing hydrolysis, starch or cellulose, they will also give you n molecules of glucose. So this is the process for the manufacturing of glucose, and you must also know that whatever extra glucose is present in our body, it is stored in the form of glycogen in our liver. The next thing is the properties of glucose. Before discussing about the properties of glucose, we should first know about the structure of glucose. So glucose consists of one aldehyde group, 4 secondary alcoholic groups, and the primary alcoholic group. So this is the basic structure of glucose, and depending upon this we'll be discussing about its properties. The number one properties is acetylation. Acetylation means reaction of a molecule with some acetic acid or acetic anhydride. In this process, we are taking up glucose molecule. So we are writing the structure of glucose. It will react with 5 molecules of acetic anhydride. Now what happens? You should see here what are the changes we are getting here. All the H of secondary alcoholic group will be replaced by the acetate group, and one of the primary alcoholic group is also replaced by the acetate group, and with the release of 5 molecules of acetic acid. So this is the process of acetylation. The second one is the glucose also reacts with hydroxylamine. So we can see that glucose, on reacting with hydroxylamine, what happens? If this hydroxylamine, it will react basically at this aldehydic group. So it will be forming CHNOH. From here you can say that it is an oxime. Similarly, glucose also reacts with hydrogen cyanide and thus giving us glucose cyanohydrin, as you can see in this structure. So these reactions, they confirm that there is some carbonyl group in the structure of glucose. As you can see, that carbonyl group may be an aldehyde group or it may be a ketone group. So from here we can see that glucose consists of an aldehydic group. Now glucose reduces Tollens reagent, that is ammoniacal nitrate solution, ammoniacal silver nitrate solution, as well as and it also reduces the Fehling solutions. So it reduces Tollens reagent to silver, metallic silver, and Fehling solutions to cuprous oxide. So this is the reducing nature of glucose, and this reactions, what do we consider about that this reduction process of glucose? It shows that glucose consists of an aldehydic group, that we have seen in the structure also. Glucose, on reacting with mild oxidizing agents like bromine and water, it is oxidized to gluconic acid, whereas glucose on oxidation with HNO3, it forms Saccharic acid. Now the question arises, what is the difference between gluconic acid and Saccharic acid? So let's have a look at its structure. In the gluconic acids, the aldehyde group gets oxidized to the acidic group, as you can see, whereas in the case of this is gluconic acid, whereas in the structure of Saccharic acid, both the 1 and 6 carbon atoms, they get oxidized to form the acidic group, and now this acid formed, it will be termed as Saccharic acid, and it consists of, you can see it consists of 2 acidic groups. So we will be calling it as Saccharic acid. So I hope it's clear. Gluconic acid consists of only 1 acidic group, whereas Saccharic acid, it consists of 2 acidic groups. The next one is glucose on prolonged heating with HI. So when we heat glucose on prolonged heating, then we are getting a straight chain alkane, that is N-hexane. So on reacting you can say on heating, that is on prolonged heating with HI, glucose forms N. What it will form? It will form N-hexane. N means it is a straight chain. So it also symbolizes that glucose is a straight chain molecule. So this is N-hexane. I hope it's clear. Now with sodium and in presence of mercury and water, glucose is reduced to sorbitol. It is reduced to sorbitol, that is one aldehyde group that is present in glucose. It gets reduced to primary alcohol. One primary alcohol group is always present in glucose. Now on reacting with sodium in presence of mercury, it forms another primary alcoholic group. It gets reduced to alcoholic group. So now we are having 2 alcoholic groups in this structure, and it will be known as sorbitol. It will be known as sorbitol. Similarly, D-glucose, it reacts with 3 molecules of phenyl hydrogen. Students, you know that this is hydrogen. This is what? Hydrogen. If we just replace one hydrogen atom with the phenyl group, now it becomes phenyl hydrogen. So on reacting with phenyl hydrogen, 2 molecules of water is released and a glucosazone is formed, as you can see in the structure, with the release of 2 water molecules. And double bond formation will also take place, as you can see in this structure. Glucose on reaction with methyl alcohol in the presence of dry HCl gas, it forms alpha and methyl glycosides. It forms glycosides. The reaction occurs only at the OH, and this is, you can see, of the hemiacetylic carbon atom. So you can see in this structure, by replacing one H here, one O of the glucose molecule, OCH3 group has come here, and this one has combined it like this. It is known as alpha methyl glucoside, and when the methyl group is on the other side, you can see then it becomes the beta methyl glucoside. So I hope it's clear what is the difference between alpha methyl glucoside and beta methyl glucoside. Now the one thing is left, that is alpha and beta glucose. In the intermolecular hemiacetal formation, you must have seen, that is in the cyclic structure, the CHO group gets converted in the CHOH group, which can have two configurations. So in the alpha form, you can see that the OH group is present on the right side, whereas in the case of beta form, the OH is present on the left side. So configuration about C1 is, this is the alpha glucose, and if you see that the hydroxyl group is present on the left side, then it is the beta glucose. So this is the difference between the alpha and beta glucose. The carbon C1 is now known as anoveric. This carbon is known as the anoveric carbon, and such compounds, they are known as anomers. Both these forms, they are optically active, and you can see that glucose has specific rotation of 111.5 degree, whereas beta glucose had a specific rotation of 19.5 degree. If you look at the cyclic structure of glucose that is given by Hibbert and Hurst, we can see in the structure that this is the structure of alpha D glucose, in which you can see the difference between alpha and beta D glucose is just of OH group. You can see that at carbon 1 position, here the OH is pointing downwards, whereas in the case of beta D glucose, OH group is pointing upwards. So this is the difference between the cyclic structure of glucose. And if you look at the structures in the chair forms, we can see this is alpha enomer and this is beta enomer. If you look at the structure of alpha enomer or beta enomer, you can see that a chair shaped structure is formed. Now this chair shaped structure, if you want to make it, is just bend the carbon at the 2 and the 5 position inwards. You will get a chair form. So you can draw easily the structures of the cyclic structure as well as the chair shaped structure. That's all, students. Whatever I have told you about glucose, just go through it, and definitely the questions will come out related to this topics. Thank you for watching my video.